Hello all, myself Chinju Krishna, Assistant Professor, Department of Information Technology, Rajagiri School of Engineering and Technology. Today I'll be discussing on Introduction to Embedded Systems. This topic belongs to the subject Embedded Systems.
The topics are Introduction, Application Domain of Embedded Systems, Disable Features and General Characteristics of Embedded Systems, Model of an Embedded System, Microprocessor and Microcontroller a comparison, Example of a simple embedded system, and Figures of merit for an embedded system. Let's go to Introduction. The term embedded system has become very common, but it's quite difficult to define. An embedded system is an electronic system which is designated to perform one or a limited set of functions using hardware and software. Having hardware and software makes an embedded system a computer, but this computer performs only a limited set of functions. Thus, exclude a PC from embedded system world, the name it as a general purpose computer. Therefore, an embedded system is a special purpose computing unit, meaning that it has a processor and associated software. The software associated with the application is built into the ROM of the processor, then it can be called as the firmware. Take the case of automobile, for example, a car. It has a number of electronic control units as part of what is called automobile electronics. Each of these units has a processor which controls one or other of the various parts of the car such as engine, brakes, lights, doors and so on. Thus, embedded systems are ubiquitous, that is omnipresent within an automobile and adds intelligence to the operations of the vehicle as a whole. The application domains of embedded systems are consumer electronics, household appliances or house security systems, automobile controls, handheld devices, medical equipment, banking, computer peripherals, networking, factories, aviation, military, robotics, and toys. Desirable features and general characteristics of embedded systems are it should have one or a small set of functions which it is expected to perform efficiently. It should be designed for low power dissipation because many systems are battery powered. It has limited memory, limited number of peripherals. Applications are not meant to be alterable by the user. Many of them are not accessible directly and they need to be highly reliable. Many of them need to be operated with time constraints also. The personal computer PC is not considered to be an embedded system. The reasons are the PC has a large application set from word processing, computation to communications, printing, scanning, and many more. Low power concentration is a good idea, but it's not a design principle in its design. Memory is available in various forms like RAM, ROM, secondary memory devices like hard disk, CD-ROM, etc. And the memory can be added if the user desires. Since PC is not used for various applications, the applications can be added on demand. And PC can be accessed by input devices like keyboard, mouse, modem, etc. And PC also needs to be reliable, but since it's unlikely to be the part of very critical system, it can afford to fail once in a while. And the applications on the PC need to be fast for better performance, but usually there is no time criticality involved. The model of an embedded system consists of a processor, actuators, memory, sensors. It's shown in figure. An embedded system consists of a processor, sensors, actuators, and memory. It's shown in figure. The idea is that any application should be able to provide the solution to a real-world problem for which some data is to be read. And for this data reading, the sensors are needed. And this data is processed by the processor, and the result of this is given to the actuators, which actually performs the appropriate actions. This gives the idea about the difference between microprocessors and microcontrollers. Processor is the brain of an embedded system. This simply means that there should be some computation engine as the core of the system to make it intelligent. There are two types of processor units in general. There are microprocessors and microcontrollers. The microprocessor unit, the main part is MPU chip, that is microprocessor unit chip, and the components connected via the system bus are RAM, ROM, parallel I/O, serial I/O, counters or timers and other peripherals. A processor like 8086 or its advanced version like Pentium has a high computational capability. It does not have pins or the internal architecture to interface with the external world. For such microprocessors, external chips act as the peripheral controllers. For example, to connect to an LCD display to an MPU, a parallel port IC is to be connected externally to have a serial transmission facility. An external serial controller is necessary for timing and counting. External timers are needed. Memory can also be connected externally. Figure shows an MPU chip connected to the peripherals and memory which are physically external to the chip. Such MPUs are used as the core of general purpose computation systems, where the emphasis is on the computational power rather than interfacing capability. A PC uses MPU, that is, the number of external chips together act as a chipset which act as the controllers to various peripherals. An MCU with peripherals and memory inside the chip is shown in figure. Here, the processing unit has timers, parallel ports, serial ports, RAM, ROM, etc. along with it. So, no external controller chips are needed. Memory is also available inside the chip. The program code is burned into the internal ROM and application code is run with the help of internal RAM. Thus, this is more or less a self-contained single-chip computer. Popular microcontrollers are 8051, PIC, AVR, ARM, etc. When an MCU has a lot of peripherals inside, such that the design of a large system is possible with these peripheral controllers itself, the system is called system on chip. We usually hear the terms like ARM SoC, Cypress P SoC, that means programmable system on chip, which are very popular. The pictures of some popular MCUs are shown here. Figure shows a simple temperature monitor. An MCU is considered the brain of the system, which functions as a temperature monitor or controller. A sensor reads the temperature and an ADC, analog to digital converter, inside the MCU converts it to digital form. This data is compared to a reference temperature, and if it is above the allowed value, an alarm is activated. Also, an output from the MCU is used to start a cooling fan to reduce the temperature. There is a digital display of the temperature as well. Thus, the output actuation consists of the following: display of the temperature value, alarm, motor which controls a cooling fan. The input is just a temperature sensor. So this temperature monitor system is a very simple system. The program continuously measures the temperature at the sensor with a delay of T between the readings. This delay is obtained from the timer inside the MCU. There is an ADC inside the MCU to convert the analog value to the digital. The output display is also refreshed at the same rate as the rate of reading the input temperature. The program is written, tested, burned into the ROM of the MCU. This program runs continuously. The circuit is put on PCB, packed inside an enclosure, and it becomes a product. The user simply places it in an area where he wants to measure the temperature. Now, if the program is to be changed, the designer has to interface. The user cannot do anything to the finished product. The temperature monitor system can have a user interface by adding a keyboard at the input side. For example, if the reference temperature is allowed to change by the user, this keyboard with a password, it's optional, can be used. The keyboard is interfaced with an interrupt, that is, when a key is pressed, the ISR, interrupt service routine, is activated, which checks the password and allows the user to change the reference temperature settings. Next is the figures of merits for an embedded system. They are low power dissipation, small physical size, small code size, high speed of response.
The reference is Embedded System and Integrated Approach by Laila Bidas. Thank you.